So now let's do question number 5 part 7, and here we have sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta, that we have to prove equal with tan theta. So let's start with the LHS again. So here LHS is sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta. So you know we have here sine theta and here we have sine cube theta. So sine theta we can take as common. So how much we left with? We left with 1 minus 2 sine square theta, okay, divided by, from here also we have cos cube theta and here we have cos theta. So from these two, what will be the common? Cos theta. So we will be left with how much? Twice cos square theta minus 1. Yes or no? Then look here, I will write 1 minus 2 sine square theta divided by cos theta, and I'm just writing look carefully, our cos square theta is nothing but 1 minus sine square theta. We know that, yes or no, from identity 1. So that only I'm going to use, okay. So I will put this under this bracket. So here I have 2, so I will be writing 2, then within bracket I will be writing the value of cos square theta. Cos square theta is how much? 1 minus sine square theta, then we have minus 1, okay, then close the bracket, okay. Then let's see how much we will get. So sine theta into 1 minus twice sine square theta divided by cos theta, okay. Then you know within bracket I will be multiplying 2 ones are 2, so I will be getting how much? 2 ones are 2, then plus minus minus 2 sine square theta minus 1. Yes or no? So now tell me, first of all let me write the numerator, as I am not doing any changes in the numerator. So it will be 2 sine square theta divided by cos theta. Tell me 2 minus 1 is how much? It is 1 minus 2 sine square theta. So look here, these two things are exactly same. So we are left with sine theta by cos theta. So sine theta by cos theta, we all know it is tan theta, which is our RHS, hence proved. So now let's do question number 5 part A. Here we have sin A plus cosec A whole thing square plus cos A plus sec whole thing square, that we have to prove equal with 7 plus tan square A plus cot square A. So let's start with our LHS. So our LHS is sin A plus cosec A whole thing square plus cos A plus sec A whole thing square. So you know here we will be using A plus B whole thing square. So how much is A plus B whole thing square? It is A square plus B square plus twice AB. Then for this part also we will be using A plus B whole thing square. So it will be how much? It will be A square plus B square plus twice AB. So look here carefully, sine square A plus cos square A is how much? 1. Yes or no? So first of all let's arrange them together. So sine square A plus cos square A, I'm writing them together. Then cosec square A, I'm arranging it together with sec square A. Then look here, this part I'm writing as 2 sine A cosec A. Then I'm left with 2 cos A into sec A. So sin square A plus cos square A is how much? It is 1 plus cosec square A, we know it is 1 plus cos square A. Okay, and sec square A is nothing but 1 plus tan square A. Okay, and here 2 sin A, cosec A is nothing but 1 by sin A, and here we have sec A is the reciprocal of cos, we know that, so it is 1 by cos A. So here look carefully, sin A by sin A gone, we are left with 1, and cos A with cos A gone, we are left with 1. Okay, so further solving it, let's see how much we are getting. Okay, so look carefully, further solving it. Here we are getting 1 plus 1 plus 1 is how much? 3 plus cot square A plus tan square A plus, see, sin A got cancelled with sin A, yes or no? So we are left with how much? 2 ones are 2, yes or no? And here also we are left with 2, since cot got cancelled with cos, yes or no? So look carefully again, so it will be how much? 3 plus 2 is how much? 7, yes or no? 7 plus cot square A plus tan square A, which is our RHS. So hence proved. Okay, so this was our RHS. You can clearly see this. So let's do question number 5 part 9. And here we have cosec A minus sin A, whole thing getting multiplied with sec A minus cos A, and that must be equal to 1 by tan A plus cot A. So let's start with our LHS. So our LHS is cosec A minus sin A, the whole thing getting multiplied with sec A minus cos A. So we know that cosec A is nothing but 1 by sin A, and we also know that sec A is nothing but 1 by cos A minus cos A. Here we are doing, you know, fraction subtraction, so the LCM of sin and 1 is sin A, yes or no? Then in the numerator we will be getting how much? 1 minus sin square A. Okay, then here LCM of 1 and cos is cos A, so since the denominator are same, so we'll have 1 only here, and here 1 into how much will be cos, so 1 into cos will be cos, so numerator will get multiplied with cos, so cos into cos will be cos square A. Now tell me, how much is 1 minus sin square A? We know from identity 1 minus sin square A is cos square A divided by sin A, and here 1 minus cos square A will be how much? It will be sin square A divided by cos A. This sin A get cancelled with one of the sin A, and this cos A got cancelled with one of the cos A, so we are left with sin A into cos A, yes or no? But that is not equal to our RHS. That means RHS we have to prove it individually. Okay, we have to further solve it. Okay, so we have to further prove, find the value of RHS, and it will be equal to sin A cos A. So let's do that. So let's do that. RHS is how much? 1 by tan A plus cot A. So 1 by tan A, we know it is sin A by cos A, and cot A is nothing but cos A by sin A. 1 divided by, what is the LCM of cos A and sin A? So obviously nothing is common, so it will be simply multiple of these two. So it will be sin A cos A, and here since we have cos here, so cos will be multiplied with how much to get sin A cos A? So cos should be multiplied with sin A to get sin A cos A, yes or no? So numerator will get multiplied with sin, so it will be sin square A. And similarly, since we have sin here, so what should be multiplied with to get cos A? So sin should be multiplied with cos to get sin A cos A. So cos into cos will give you cos square A. Then this is P, this is Q of the denominator. So you know Q remains in its place. Okay, P P remain in its place and Q goes up, yes or no? So we will get how much? Sin A cos A divided by sin square A plus cos square A, and sin square A plus cos square A is nothing but 1, yes or no? So sin A cos A divided by 1, okay, will give us how much? Sin A cos A by 1 is nothing but sin A cos A, which was our RHS, yes or no? Which is our RHS, hence proof. So we have to prove these three parts as equal. So the first part is 1 plus tan square A divided by 1 plus cot square A, and let's try to solve it. So we know 1 plus 1 plus tan square A is how much? 1 plus tan square A, it is 1 plus tan square A is nothing but we know it is sec square A, and 1 plus cot square A is nothing but cosec square A, and sec square A is nothing but the reciprocal of cos square A, and cosec square A is nothing but the reciprocal of sin square A. Okay, this is P, this is Q, this is P, this is Q. We know that the P remains in its place, so 1 and 1 remains in its place. Okay, Q of numerator goes down. Similarly, Q of denominator goes up. So ultimately it is 1 by 1, and sin square by cos square is nothing but tan square A. And let's check this part now. So that part is 1 minus tan A by 1 minus cot A whole thing square, and we know that can be written as 1 minus tan A whole thing square divided by 1 minus cot A whole thing square. We know that if x by y whole thing square can be written as what? X square by y square. So similarly, I have written 1 minus tan A by 1 minus cot A whole thing square as 1 minus tan A square divided by 1 minus cot A whole thing square. Okay, so now let's use identity. Okay, 1 minus tan A whole thing square is how much? We know the formula of A minus B whole thing square, so it's A square, okay, plus B square, okay, minus twice AB. Similarly, in the denominator we'll have A square plus B square minus twice AB. So it is how much? 1 plus tan square is how much? 1 plus tan square from identity 3 we know it is sec square A. Okay, it is sec square A minus 2 tan A divided by cosec square A minus cot A, 2 cot A. So we will have to further solve it. So we know that will be equal to sec square A minus 210A divided by cosec square A minus 2 cot A. I can solve this as something like this. See, sec square A is the reciprocal of cos square A. Yes or no? So I can write this as 1 by cos square A. Then minus 2. Then A can be written as sin A by cos A divided by cosec square A can be written as 1 by sin square A, and minus 2 cot A can be written as cos A by sin A. So look here how much we will be getting in the next step. So see, cos square A and cos A, we can take LCM, and LCM will be how much? Okay, so LCM will be cos square A. Okay, cos square A and cos A. LCM will be how much? First we'll have to see the common stuff. So look here, the common between cos square A and cos A is cos A. So we left with how much? We left with cos A and 1. So cos A into cos A will be how much? Cos square A. So that is the actually LCM of, okay, cos square A and cos A. So in the denominator we have a cos square A. Since the denominator is same, we can write the stuff which is there in the numerator. Then here we have cos A and here we have cos square A. So cos A will get multiplied with cos A to get cos square A. So that numerator will be multiplied with cos A. So it will be twice sin A cos A. Similarly in the denominator also the LCM will be sin square A using the same concept. Okay. So since the denominators are same, we can write the numerator, the thing which is there in the numerator as it is. So sin A will get multiplied with sin A to get sin square A. So again the numerator will get multiplied with sin A. So we will be getting how much? Twice sin A cos A. Look here carefully. P are same. This is PQ, PQ. So P is same. So if the P is same, it will get cancelled with each other, and we will be getting how much? We will be getting 1 by cos square A divided by 1 by sin square A. So again this q will go down and this q will go up, so it will be sin square A divided by cos square A, which is nothing but tan square A. So we can clearly see that part, this part and this part and that part is equal, since the value of one first part was also tan square A, second part was also tan square A. So we can just conclude by writing, we can simply conclude by writing that clearly 1 plus tan square A divided by 1 plus cot square A equal to 1 minus tan A divided by 1 minus cot A whole thing square equal to tan square A. Hence proved. Hence